Hello everyone, today we'll be starting with the syllabus of our O-level physics with physical quantities and measurements. So let's start with the first statement. Measurement is the quantity of an attribute. I know this statement may sound a little daunting, but don't be afraid. What this means is that we've got attributes such as length, time, and mass, and if we measure these attributes, we simply get a measurement. Now there are two kinds of attributes. Some that we can measure, such as length, time, and mass. We can measure them in meters, seconds, and kilograms, and so on. However, there are a few attributes that we cannot measure, such as emotions like anger, pain, or hunger. We can't measure these emotions with numbers. So these are attributes that we cannot measure. An important thing to remember about measurements is that they always have an SI unit. What this means is that length here will have a SI unit, for example, of meters. Time has an SI unit of seconds, and mass has an SI unit of kilograms. And these measurements are taken through instruments. Now we'll talk more about this in detail, but to understand, we use different tools to measure these attributes. So let's start with length. Okay, so let's talk about length. The SI unit of length is meters. Now what SI unit means that it is a universally accepted unit, which means that most countries of the world agreed that we are going to measure length using meters. After they decided meter to be the SI unit of length, there was another problem of how would they represent very large lengths or very small lengths. For example, if there is distance between two towns A and B, the distance is 60,000 meters. 60,000 meters is a very big number, and it is very hard to represent if you want to tell someone again and again. So rather than saying 60,000 meters, we just simply say 60 kilometers. Now what scientists did is that they used prefixes, powers of tens. For example, they said that rather than writing 1000 meters, we'll just simply write 1 kilometer. So rather than writing 60,000 meters, we just simply write 60 kilometers. The same goes for very small values. For example, the diameter of a cell. If it is 0.001 meter, this number is very hard to read. So what we do is we simply write 1 millimeter. I've got all the prefixes and powers of tens that you need to remember, so make sure to learn most of them at least. Okay guys, so let's talk about the instruments that we use to measure length. The first one is measuring tape. Measuring tape can be used to measure lengths longer than 1 meter because as we can see that this measuring tape is 3 meters long. They are flexible and can be used to measure curves. Like if you want to measure the circumference of a football or a round table, we can use a measuring tape. They have a precision which is 1 centimeter or 1 millimeter. Now before explaining this point, I would like to point out what precision is. To understand this, let's take two measurements. The first measurement is 25 centimeter and the second is 25.45 centimeter. If we look at these measurements, the second measurement has an extra 0.45 centimeter of accuracy while the first one does not. This means that the second reading has a higher precision than the first one. The precision of the first reading is 1 centimeter while the precision of the second reading is 0.01 centimeter. I hope that makes sense. So let's talk about the measuring tapes. Now let's understand with the 1 millimeter measuring tape. If you've got a measuring tape with a precision of 1 millimeter, we're going to be getting readings down to the 1 millimeter. Now what this means is that we'll get for example readings like 30.1 centimeter or 30.7 or 2.1 centimeter. We can't get readings more precise than this. For example 2.15 or 6.28, because to get readings like these we need a instrument with a higher precision. Now let's move on to the meter rule. Meter rule is used to measure lengths shorter than 1 meter. That is because, as the name suggests, the meter rule can only measure lengths up to 1 meter. It also has a precision of 1 millimeter. Next up is micrometer. Now micrometer is an instrument which we can use to get more precise readings, as it has a much higher precision of 0.01 millimeter. Now I'll teach you how to use a micrometer. The first step is to put object in jaws and tighten it using the thimble until it's firm. Next we'll get the main scale reading nearest to the 0.5 millimeter, and then we'll add the reading from the circular scale into the main scale reading. Let's do an example. So for this micrometer we've got a zoomed in picture for the main scale and the circular scale. If we look closely, we've got 1, 2, 2.5 millimeter on the main scale, and 15, 16 and 17th marking on the circular scale. So the first thing we'll do is that we'll write the reading on the main scale, which is 2.5 millimeter, and then we're going to add the reading from the circular scale. As the 17th marking coincided with the main scale, we're going to be adding 0.17 millimeter. This means that 2.5 plus 0.17 gives us 2.67, which is the measurement for this object. Now we're going to do an example of our own. If you want, you can pause the video here and try this on your own to check if you understood the concept. Okay, I hope that you got it right. Now let's do it ourselves. If you look at the main scale, you've got 1, 2, 3. We've got 3 millimeters on our main scale and 21 and 22 on our circular scale, which means that you have to add 0.22 millimeter on the circular scale. Now if we add these, we get 3.22 millimeter, which is our final answer and the reading for this micrometer screw gauge. Moving on, we can measure time using two instruments, an analog stopwatch or a digital stopwatch. Usually digital stopwatches are much more precise with a precision of 10 milliseconds, while the analog stopwatches have a precision of only 20 milliseconds or less. We also have pendulums in our syllabus, so let's talk about them. So first of all, what a pendulum is basically. Pendulum is a bob connected with a string, while the other end of the string is connected between two metal plates or hung somewhere. Now we take the bob, move it to the right or the left and let it go. The pendulum bob swings and we basically get a pendulum. So if we look at our example over here, we had a bob, we took it towards the left, and if we let it go, our bob is going to swing towards the right, come to a stop, and then come back to left again. This whole cycle is one period. A bob swinging towards the right, stopping and coming towards the left, back to its original position is one whole period. Okay, so now we're going to be talking about some errors. So let's start with the parallax error. In the first example, we can see that the wrong eye has the line of sight which is not perpendicular to the scale, due to which we get a wrong reading, while the correct eye has a line of sight which is perpendicular to the scale, so we get a good measurement. Next, we have a systematic error. So let's talk about the systematic error. The length as x is the extra and your reading will always be higher. What this means is that if you've got, for example, in this example, you've got a point P and you want to measure point P, and if we try to measure it, we can see that the scale shows the length is 6 centimeters. However, we can also see that there is a distance x extra unaccounted for from the bottom. Now what this will do is that whatever reading we get for P, our reading is going to be higher than the original reading. The easiest solution to this is that we calculate x using another scale, for example, and then we subtract x from our original reading. Now we're going to be talking about Vernier scales and how to use them. So in this example, we've got an object fitted into the Vernier scale, and now we're going to take out the reading. The first step we do is look at the main scale. On the main scale, we can see that our object is between the 1.3 centimeter and 1.4 centimeter mark. This gives us a hint that our object is between 1.3 and 1.4 centimeter. Now to get even more precise than this, we look at the side scale and look for a mark that coincides with the main scale. I'll zoom in a bit. So the first mark does not coincide, the second also does not, the third also does not, but if we look at the sixth mark, it coincides perfectly with the main scale. So we know that the sixth mark is correct. Now what we do is that we take our original main scale reading, which is 1.3, and add 0.06 centimeters into it, because our sixth marking on the side scale coincided, and then we get our final reading of 1.36 centimeter. Next we have the volumes. Now before we start the volume calculation using water displacement, I want to talk about regular objects. Regular objects are objects with a defined shape, such as for example a cuboid or a cylinder. These objects have a mathematical formula that we can use to calculate volume, such as the cuboid can be calculated using the formula length multiplied by width multiplied by height, and the cylinder can be calculated using pi r square h. But when we get irregular objects such as pieces of rock which don't have a defined shape, we need to use the water displacement method. So let's talk about the water displacement method. The first step for the water displacement method is to measure volume of a measuring cylinder with water. This is our first reading, V1. Then we place the object into the measuring cylinder and measure the volume again. This is V2. Now we subtract the initial volume from the final volume to get the volume of the object. So we'll subtract V1 from V2 to get the volume of the rock. Another very important concept in this chapter is average. Now if we take a measurement, it is very possible that the first measurement we take or the second measurement we take, it might be inaccurate due to human error. So what we want to do is that we want to take a bunch of measurements and then average them. So for example, in this example we want to take out the width of this rectangle. We take 5 readings for the width L and then we average them. We average them by adding them all together, all the readings, and dividing them by the number of readings. So we'll do L1 plus L2 plus L3 plus L4 plus L5 divided by 5, which is the total number of readings. This is it for this video, and this chapter is divided into 2 parts, so I'll be uploading the second part soon. Thank you for watching.